Hey everybody, today we're going to have a quick look at this Sun server that I've got. I picked this up, it was a few weeks ago now. You might have also seen a video that I did asking for help for drivers and stuff for it. I was trying to get Windows Server 2003 installed on it, which I have managed to do. It's all working perfectly, or it seems to be. So what I want to do is just do a quick video about the architecture on this machine, because it is a little bit unusual. So first off, I just want to say thank you to the anonymous person who got in contact through a friend who managed to provide me with all of the original Sun installation CDs. That was really useful. I would not have been able to get this running without them. Unfortunately, you can't download any of this stuff from Sun, which of course is now Oracle, because they don't allow you to download anything without a service contract, if you ask nicely, on a blue moon, standing on one leg with a huge grubby wedge of cash in your pocket. So thankfully this guy in Singapore managed to provide me with copies of the CDs, which is awesome. So thank you very much, Mr. Anonymous. So I picked this up a few weeks ago. It cost me 30 quid. I was in kind of two minds whether to get it or not. I thought it might be full of copper heat sinks. Yeah, but there's probably not £30 worth of copper in it. But I thought it'd be interesting to have a look at some sort of mid-range server stuff. Now, it was actually listed as not working. When they powered it up, they couldn't get anything on the screen, and there was a fault light showing on it as well. But that all turned out to be a bit of a myth. You just needed to plug all the power cables in and let it power up. It takes about 40-50 seconds for the actual for anything to appear on the video display. So they might have thought it was faulty, but in fact it wasn't. So this is a Sun Fire X4600, dates from 2006. I believe they were released shortly after 2006. This is a bit of an unusual one because it, as you can see, this sticker up here, it says Sun Microsystems Early Access Evaluation Unit. So this would have been sent out to probably their most preferred customers to evaluate and decide whether they want to buy it or not. Now, from what I've seen in some of the service processor settings is a number of IP addresses which trace back to UBS Bank in London. UBS is a Swiss bank, and they have an office in London, and that's where the IPs seem to be allocated to. So looks like this might have been used at UBS for some banking something or other. Sun's first 8-way x64 architecture machine, so it runs AMD Opteron processors. There's 8 of those, and each one of those is dual core, so we've got a total of 16 cores. The actual processor model number is the Opteron 885. The spec on this, it probably would have cost around about $68,000 to buy this server back in the day. It's a 4U rack unit, weighs about 50 kilos. At the front here we have a number of hard disks. We've got four-way RAID hard disks in the front here. We've got a set of 4 fans. They're all dual redundant. And then we have all the processing and power supplies in the back. Right, so if I go handheld, just to make it a little bit easier to get around this, we've got 4 power supplies at the back. These just come out on these retention clip things. So these just slide out. These are hot swappable. You actually only need 2 of these to actually run the system, but it has 4 for dual redundancy. This also means that you can have 2 power supplies running off one electrical circuit, and then you can have the other 2 running off another. So it provides better resiliency. These power supplies actually work together, they team. So if you have 4 of them plugged in and powered on, then they actually share the load, so that each one would only be doing 25% of the work. So presumably that makes it last longer as well. Along here we have the processor card slots. So just in here we've got PCI X, PCI Express. Here we've got the console video output, remote management port. That's serial. We've got a couple of indication lights, a couple of USBs, the remote management Ethernet port, and then lastly we've got 4 gigabit Ethernet ports. And round on the front panel we've got a massive big ventilation inlet for the fans. On the end here we have the 4 hard disk bays. These top ones, these are just fillers, they don't actually take discs. In fact, when I picked this up, it didn't have any actual hard disk caddies in them. There were all these fillers, so I suspect it had been booting off a network or a SAN or something. So I've actually gone out and I've actually bought a small SAS disk and a couple of the caddies, just so I can put a disk in it and actually get it running. Yeah, so there's not really much on the front here. We've just got a couple of USBs on the front and some status slicers along the top. These fans are huge, great big things with these lovely quick release things on them. So we can pull out the fan there. As you can see, it's pretty big. So it's an EBM Pabst, and that is rated at 24 volts, 4.5 amps, 108 watts each. So yes, you can probably imagine it's not very quiet. It's pretty loud when it's running, but it does have 2 fan speeds, a lower one and a higher one depending on the ambient temperature. Now the fans do actually have a fault indication light on as well, so if the fan fails, it just lights up and makes it easier for identifying which, if you do have a fan failure, which one has failed. The power supplies, as I said, there's 4 of these. These are manufactured by Aztec, which is a good make. We've got model DS850-3. Universal input. The outputs are 3.3 volts at 6 amps and 12 volts at 70 amps. So yeah, that's a pretty compact power supply for 850 watts. Okay, let's take the lid off this. There's just 2 thumb screws just here. Okay, so you can see there we've got the main system board, which is a large PCB which runs down to about down here, which is where the fans then are installed. We have 8 processor modules, each with their own RAM. Those plug into slots on here and plug onto the motherboard, which is at the base. So the keen-eyed and the knowledgeable out there will be realising that this is not your standard PC architecture design, which is generally called SMP, which is symmetric multiprocessing. This uses a slightly different technique. It's called NUMA, which is non-uniform memory access. Basically what that means is each processor has its own dedicated memory. There is no front-side bus that you get on SMP architecture. Generally that's because once you start getting too many processors or cores, the front side bus just gets clogged down with too much traffic of all those cores trying to access the same memory. So in NUMA, the memory is connected directly to each CPU. Each CPU can access all of the memory in the system, but it has to go through links and steps to actually be able to access them. So the memory access times when, say, processor on this card needs to access memory here, there is a penalty to pay. So you generally need to have an operating system which is NUMA aware, and you need to have applications which are NUMA aware as well, so they can make sure that the processor on this board here is only really using the data which is stored in its own local memory. Otherwise you will lose your performance. So if you have this particular architecture, you don't have a front-side bus, how do the processors talk to each other? Well, what is actually in use on this system is hypertransport. Hypertransport is a system that was developed by, funnily enough, AMD and Sun and a few other people. It's a high-speed point-to-point packet-based interconnect, which is really designed for connecting CPUs together in a high-speed link. In this situation, each of the processors actually has Hypertransport built into it. Each processor has 3 Hypertransport links, so that allows 3 connections to other processors or out to I/O systems. So thankfully this is a nice block diagram of the system that I managed to get from a white paper that Sun produced when they had this system available. So it shows each of the 8 processors running along the top here, and then the rest of the system below it. Each of these lines here along the top and along the bottom are the Hypertransport links. You can see here, for example, on CPU 2 there are 3 links coming out connecting to other processors, and on the end, which is CPU 0 and CPU 7, one of those Hypertransport links is used to bring a connection down to the rest of the subsystem. So we have the PCI X tunnel here, and we've got an NVIDIA South Bridge and its sort of partner processor on hanging off CPU 7, which is an I/O expansion. The Hypertransport implementation on this, as I said, there's 3 links which go out to each 2. If you're not processor 0 or 7, they just connect to 3 other CPUs. So there's various link configurations here. The Hypertransport on this system runs at 4 gigabytes per second. Now it's full duplex as well, so you get bidirectional for that. So effectively it is 8 gigabytes per second. The CPU to the local memory is actually connected at 6.4 gigabytes per second. That uses PC3200 RAM for that. So you can see that there is a penalty to pay if you have to connect to memory through the Hypertransport links. Now, as I said before, Hypertransport is a packet-based system, so you're probably not going to get the full 4 gigabytes per second either. Once you've accounted for packet overheads and things like that. So there is probably a fair penalty to pay if you need to start shuffling things around between processors. Right, if we have a quick look at the motherboard, there's no cards plugged into this, although one of the little backplane cover things is missing, so it looks like there was something plugged into one of these PCI X slots at the back here. Might have been a host adapter or something for a SAN or something like that, I don't know. So we've got the 2 PCI X slots, 3 PCI Express. This board here is the ILOM service processor, and then just beyond that we have another 3 PCI Express. The ICs on this, that is the LSI RAID controller. This device here is the AMD PCI X tunnel, so yeah, logically that's over this side next to the RAID controller and the PCI X slots. This device here is the NVIDIA CK804, which is the South Bridge, and this is the NVIDIA IO04, which is the IO expansion. These modules standing off the PCB here, those will be voltage regulation modules. I mentioned earlier the power supply is only output 12 volts, so that's brought onto the board, and then there's local voltage regulation done with these modules. Right, I will just remove one of the processor modules out. You have to be careful with these because they're probably not designed to be taken in and out too many times, so let's just eject that out. There's just these plastic eject doohickeys, so let's just pull that out. So here we've got one of the processor modules. We've got a huge copper heatsink. That is a very fine finned heatsink on there with a huge lump of copper on the bottom of it. These look like voltage regulation modules. Again, the 12 volts that come from the power supply will come up onto these boards, and these will drop the 12 volts down to whatever the core voltages are of the CPU. We have the 4 memory sticks. Those are 2 gigabytes each. PC3200 and ECC. Right on the bottom there we have the hypertransport sockets, and there's a few little odd things around here. There is actually a super cap just down in here. The ILOM, which is the Surface processor, can do some quite clever things with this if there's any failures on these boards. For example, if one of these memory modules fails, it can actually light up the slots here. These eject tabs are actually clear because there's actually an LED below them, so you can actually take this board out completely unpowered and press a button here, and the super cap, it has enough power in there to light up the LEDs to indicate which DIMM has failed, and I think there's a couple of other status and fault indication LEDs on here as well. And here we've got the hypertransport connectors. I'm not sure if those are actually gold plated. They could well be. I'm not sure whether they're metal or plastic, it's hard to tell. But you can see in there little prong things. Those look really, really seriously expensive connectors to me. And now I've removed that module out of this slot here, you can actually see these two. You can just about see the second one there. These are actually the bus bars from the power supplies. These are two big metal connections, which have obviously been powder coated blue, which run down and attach to the base of the motherboard. So yeah, given you need two of these power supplies to run the system, potentially looking at up to about 140 amps running through those bus bars when it's on full load. Right, I just want to speak briefly about the ILOM system, because it is kind of interesting. It's basically a complete system on that little board. It runs a Motorola MPC82485P, which is a PowerPC based processor. As you can see, it's got 32 megabytes of flash and 64 megabytes of SD RAM, and that provides all the web interfaces and the serial port interfaces to the management system. You can do pretty much everything on there. You can log in and you can look at all the temperature sensors. You can turn the system on and off, and you can also do redirection of keyboard, mouse, video, floppy drive and CD drive, etc. So that's all provided through ILOM. There is once you log into the actual ILOM system, there is actually a Java client which allows you to do the video redirection. That's done through a link here. There's actually a ATI Rage XL video chip on the system board which provides the VGA output. That actually has two links you can see here. So one is the analog VGA video which goes out to the rear port, and then it looks like they've used the DVI port from that chip, which runs into the ILOM processor, and there is actually an FPGA on that board which takes the DVI video and does whatever it needs to do to convert it into a format which is then sent out over the network port to the remote client. As I said, it can also redirect the floppy drives, CD drives and all that sort of stuff. That is actually done through a number of USB links between the ILOM processor and the NVIDIA CK804. So those are all provided via USB. So because all of this is done sort of virtually, you've got redirected keyboards, redirected video, you can actually power this on and actually go into the BIOS remotely, make changes, save and then reboot. You don't actually have to come to the physical machine barely at all unless something actually physically happens with it. Now in terms of how much grunt this machine has, I've done a few benchmarks on it. Now I've got Windows running. First thing I tried was Handbrake, which is a 64-bit Windows application done for rendering MP4 videos. I tried that. That didn't prove to be particularly good. It came out about the same speed as my Core i7 3770K CPU, which is in my desktop PC. So that came out about the same. I suspect that was probably down to it not being particularly NUMA aware, well, not NUMA aware at all. So I would imagine that the application and the video file it was producing sat in the 8 gigabytes of RAM that's on processor 0, and all of the other cores were having to jump through the hypertransport links to access that memory, so that probably just ruined the performance. So I started thinking about it, and I thought what we need is something that's purely computational. So I remembered fractals. I've always been fascinated with fractals, so gave that a try. I've got a program called Fractal Extreme, which is a full multi-threaded application, and that works really, really well on this machine. In some cases, it's about twice the speed as my Core i7 in my desktop. So for purely computational tasks, it's still doing pretty well, considering it is 10 years old. So if you're interested in fractals, or maybe you don't know what they are, I do actually have a new channel where I've posted up some of the fractal videos that I've created with this machine. So if you want to go and check that out, there'll be a link just about here somewhere. Go check it out. And before any of you start saying about, oh well, the cost per watt hour of computing power in this is totally pointless, I shouldn't be using it at all, I should be just using something else. Well, yes, I totally agree, but sometimes it's just nice to use old technology. You know, it's like I've got a classic car sat out on the driveway that's 30 years old, and I love driving that, so sometimes it's just nice to use old stuff sometimes. Okay, I think we'll call it quits there. I don't think there's really anything else to see. Thanks for watching. If you liked it, give it a thumbs up. If you've got any comments, leave those in the comments section. I hope you enjoyed what you saw today, and I'll see you on the next video. Bye for now.